Hello, hi, namaskar everyone. Good evening. Hello, hi. Just give me a quick update. Can you all hear me? Can you all watch this? Just give me a quick update. Then after, we'll get started. So let me read it in the comment box. I hope I'm clearly audible and visible. Just give me a quick update, students. Okay, okay. So somebody is saying, I don't know even a single bit about calculus, only what I did in my boards. Can I watch this session? Sanjana, in that case, you must. You must watch it. Vardhan is saying a lot of comments I can see. So give me a quick update, students. Can you all hear this? Can you all see this? Let me see how's it all going. Great. So good to have you all. Just give me a quick confirmation. Am I clearly audible and visible on the screen so that we can start it? Okay, somebody is saying I did not start calculus. Can I watch this? You should, Vardhan. In that case, if you are preparing for JEE, specifically for the April attempt, this is your opportunity. So I welcome you all in this series where we'll be revising your entire mathematics with these 3 sessions. So today is our first session where we'll be revising calculus. In the second session, we'll be doing algebra with the trigonometry. And in the third session, we'll be doing coordinate geometry and vectors in 3D. I hope you got it. Great. So good to have you all. Thish is saying waiting for your live. Good to have you. I was also eagerly waiting. I was very much excited to see you all. And since you all are here, let us get started. So hello, hi. Good to hear that you are from Andhra. A lot of students are from a lot of different states of our country. Some are watching it from abroad as well. So good to have you all. Good to have you all. Welcome you all, and let us get started. But before I get started, I hope you know when you talk about calculus, what all will be covering in this session. So of course, we'll be starting with functions. Our discussion will begin with functions, and with functions, few things from algebra also will be covering. For example, I'll today be talking about theory from sets and relations as well, because this theory will not be covering specifically or distinctly when we talk about algebra, although it's a part of sets and relations, but we'll be covering the theory here. And after sets and relations, that is after functions, when we talk about all the things, we'll move towards limits, continuity and differentiability. Then we'll talk about differentiation as well along with differentiability. Then we'll talk about application of derivatives, the concept of maxima, minima, optimization, and a lot more. And after AOD, we'll gradually move towards integration. So definite integration, indefinite integration, both will do. And once we are done with integration, of course, we'll talk about the concept area under the curve, area bounded by a region. And then finally, the crux of all of this, that is differential equations. We'll culminate this session with all of this. So entire calculus will get covered. Sir, when will the complex number one shot will be uploaded? Jivanatham, very soon. Don't worry. I have recorded it from my end, and possibly very soon it will be released. Don't worry about that. Before your April attempt, all of these one shots will definitely get released. So the process or the flow of this lecture will remain very simple. First of all, we'll revise the entire theory of calculus, and then we'll begin with the practice of questions. We'll not go like this, that theory, then some questions, then theory, some questions. We'll first of all revise the entire theory of your calculus. Good to hear it from you, Purvi. Super duper session. Thank you so much for giving it or giving this compliment. Compliments are really necessary and important. They make our day. They truly make our day. When you say so, it really inspires us, motivates us to do something better. And we all get a lot of energy from these. Sir, I'm studying only statistics, coordinate geometry, vector algebra, and 3D geometry. Do you think this is enough for getting 30 marks in maths? Unknown, I will say that it could be, but there in that case, you need to be sure of these things. That if a question comes from statistics, coordinate, vector, or 3D, you are definitely going to do it. So if you are surely going to do it, no matter how hard or how tough or how difficult it is, then I think it will be really good for you. But I'll simply suggest you one very simple thing here, students, that if you are going with this thing, that you are, keeping your coverage very low, very narrow, then you are, putting a lot of things at stake. There you need to understand and know that instead of focusing only few things in the best possible manner, here in this examination, do everything maybe superficially. That will also give you better than 30. Because what happens is that sometimes easy questions are asked from the tougher chapters, and tougher chapters are asked from the easier questions sometimes. So you should be, or mostly I'll say, so you should be aware of it. Okay, sir, I'm waiting for the one shot of the geometrical. Yes, Jivanatham. I have covered the geometrical part of complex numbers in a very great detail in that one shot. So with that, please remember this. Instead of being the master of one and jack of none, for IDJ, we always say try to be jack of all and master of none. That will be better for this examination. Good, good. Great to have you all. Now, with that, as we have discussed, the flow of this lecture will remain very simple. First, we'll do the entire theory of calculus, that is all the chapters, functions, relations, functions, then limits, continuity, and differentiability. Then we'll talk about derivatives, application of derivatives, indefinite integration, definite integration, area under the curve, and then we'll culminate it with differential equations. So theory will be done, and then we'll move towards questions and practice, and through those questions, we'll revise all the concepts. But remember, thank you so much, Kala Kaddu. Good to have you all. Good to have you all. And I'm hoping that you all stay till the session ends. I'm hoping that, right? Of course, we'll keep taking breaks. Don't worry about that. And here you remember that not entire theory from scratch is going to be covered. Only the crucial concepts, the concepts which are most highly used, which you should be aware of, or which sometimes students tend to forget. That will be covering or revising with this revision of theory. Then we'll be doing decent amount of questions to revise all the chapters. This is what we'll be doing in this session of calculus. Then we'll move towards algebra and trigo in the second session. In the third session, coordinate with vectors in 3D. So unknown, study everything. And this is your opportunity. 3 sessions, entire maths. What else do you need? Of course, this is something exaggerated statement, 3 sessions, entire maths. That does not happen like that. But yes, if you wish to revise, this is a good opportunity. Good to have you all. Now, what are we told? Cardinal number of some sets. A, B, C are finite sets and U be the finite universal set. Great. Now, when you talk about some formulae, although these formulae can be developed with the help of Venn diagram as well. So when we solve questions based on probability, I always prefer or recommend that you draw those Venn diagrams and develop these formulae. But these formulae can very basically or directly be understood that probability of not happening of A is equal to 1 minus probability of happening of A. I hope you are understanding how am I relating this formula with the formula of probability. So this is what you study when you talk about sets, but I hope you are realizing that these formulae are as it is in the same fashion used in probability as well. When you talk about A union B, we all know nothing much is needed to be said about this, but here we remember if A and B are disjoint non-void sets, which means there is nothing common between them. In that case, we say that this formula becomes this, which is definitely not something huge or difficult. When you say that, sir, what about A intersection B naught? So the common part of A with the common part of B naught, which means what? Which simply means, sir, out of A, if you simply remove A intersection B, let me correct this. There is some correction here. I'll show you how. There, please understand. Let's say I'm going to draw a Venn diagram here with this data. Let's say this is your set, universal set U, and in this universal set there is set A and there is set B, right? Now what does it mean? What is the meaning of NA intersection B dash? So A means what? This entire region where A is lying, and B naught means what? The entire region where B is not there. So when you talk about A intersection B naught, will you not say this is the region which is representing A intersection B naught, because this is the common area of A and B naught. Everybody got this? How do I get this? I think there is a small correction here. Only correction you need to make is that here instead of union, it should be intersection. Are you not realizing this? Sir, very simple forward formula here is that here if from set A intersection B is removed, I think we'll be left with A only. And that's exactly what they are asking you. So this is how you can develop or derive these formulae with the help of Venn diagram as well, even if you get confused with them. So this is how you could develop them. Something very crucial or important which I wish to highlight here is this principle of inclusion and exclusion, which you should always be aware of. For example, with the 3 sets, what happens here is that let's say if I'm talking about A union B union C. So first of all, pay attention to this. How do I personally remember this? Because with 4 sets or 5 sets, you need not remember this formula. If you could generalize this, you could do it within seconds. What does it mean? With A union B union C, what we do is A plus B plus C minus A intersection B, B intersection C, C intersection A plus A intersection B intersection C. So principle of inclusion, exclusion, then inclusion. Are you understanding my words? For example, with the 4 sets, let's say I have to develop the formula. Let's say I'm talking about A, union B, union C, union D, and number of elements I'm asked, what would be that? So first of all, take summation of NA plus NB plus NC plus NC. I hope you're understanding it. So summation of NA, which means what? NA plus NB plus NC plus ND. Good evening, Black Mystery. Good evening, everyone. Now, once you have included it, exclude intersection of 2, which means summation of elements of A intersection B, which means A intersection B, A intersection C, A intersection D, B intersection C, B intersection D, like that. So when you exclude that, principle of inclusion, then exclusion. Good evening, hello, hi everyone. Thank you so much for so much support and love. You're showering. Yeah, good to see you all. So inclusion, exclusion, then again inclusion. Inclusion means what? Summation of A intersection B intersection C, which means intersection of 3 taken at a time. So A, B, C, A, B, D, B, C, D, like that. Now, inclusion, exclusion, inclusion. So again, exclusion of 4, which means N of A intersection B intersection C intersection D. I hope you got this. So this is how you could develop the formula for anything like that, no matter how many number of sets you are given. Although as per your syllabus, you are mostly restricted to 3 sets. Now, when we talk about relation, what is a relation? We all know, you all know it better than me, but when you talk about it mathematically, I think you need more clarity on this. So let's say there is a set A, there is set B. If I wish to define relations from set A to B, all I'll be saying is that from A to B, if I take the Cartesian product, so these 3 elements 1, 2, 3, you have 1, 2 and 3 are mapped with these 2 elements 4 and 5. So in how many ways can you have these mappings? 1 with 4, 1 with 5, then 2 with 4, 2 with 5, 3 with 4, 3 with 5. All these possible mappings are there. These are the Cartesian products. So there will be how many elements? 3 into 6, 6 pairs will be there. So if out of these 6 pairs, what kind of 6 pairs, students? I'll be having 1, 4, 1, 5, then 2, 4, then 2, 5, and so on. Up till what? Up till the last term 3, 5. So these are the 6 elements in this Cartesian product of A cross B, right? Now, when you take any subset of this Cartesian product A cross B, which means what? Any subset means you take any number of elements, any subset you take. For example, let's say I have taken a subset where I'm taking 2, 4 and 3, 5. Let's say this is the subset which I'm taking, which I'm defining as R1. So this is a relation. This is a relation which is defined like this, that in its domain you are having 2, 3, and its co-domain you are having 4, 5, 2 is mapped with 4, 3 is mapped with 5. So this is one of the relations. So now the question comes. Questions are often asked on number of relations. So how do you define it? Let's say from A to B, I can see 6 pairs. How am I seeing 6 pairs? Because in the domain there are 3 elements. In the codomain there are 2 elements. So 3 into 2, 6 pairs will be formed. With these 6 pairs, how many subsets can be formed? So I hope you remember, if a set has 6 elements, the number of subsets, including 5 of course, it can have will be 2 to the power n, which is 2 to the power 6. So here there can be 64 relations from A to B. There are possible 64 relations from A to B. How did I get to this? Did you all understand this? Just give me a quick update on this. Give me a thumbs up. Have you all gotten this? Can I move ahead from here? Are you all actively listening and understanding? I hope my speed is okay. This kind of pace at which I'm running this session. I hope you are okay and fine with that. Can we go ahead with this pace only? Give me a quick confirmation and update on that. Now from here, when I move ahead, what do we see? Reflexive, transitive, and of course symmetric. These 3 relations are very important. Questions are asked on it, and a relation, whether it is equivalence or not, that is also what you are asked. Good, Purvi. Thank you so much for that. Here, reflexive, we all know, if a relation contains for its domain A, A, in its domain, that's good and known. If from its domain, all the elements of its domain are there pairwise in this A, A fashion, good, great, perfect, brilliant. Keep responding like this. This keeps us active. That yes, you all are listening and understanding, so that we can go ahead with this space. Otherwise, it is just a monologue I'm doing with a camera right there in front of me. I hope you are understanding the limitations of technology, right? So here, coming back to the discussion here, if you are from the domain set of this relation, if you are having all these pairs existing A, A, for example, if in the domain there are elements 1, 2, 3, so 1, 1, 2, 2, 3, 3 are there, then we say such relation is reflexive. I hope you can see this right there in front of you. Now, when you talk about identity relation simply means that here it is always a reflexive, but a reflexive relation is not necessary an identity relation. Identity means those domain should be mapped with the domain. 1, 1, 2, 2, 3, 3. If only these 3 elements exist in that relation, it will be an identity. So identity relation is always a reflexive, but it is not necessary that a reflexive will be an identity. I hope you're understanding my word. I hope you're understanding my word, right? So with that, when I go ahead, we talk about symmetric. I hope you know. So if in a relation, there is a pair 2, 3. So for that 2, 3, 3, 2 also must exist. I hope you know that. For A comma B comma A must be there. For example, here, when you talk about relation 2, can you help me with that? Is it symmetric or not? Can you tell me out of R1, R2 and R3, how many are symmetric? I hope you can see. R1, 1, 2, 2, 1, clearly symmetric. R2, 1, 2, 2, 1, 1, 3, 3, 1, symmetric. But what about R3? Is R3 a symmetrical relation? Can you help me with that? And why is it not? Sir, shout out to Shaurya. Okay, Spitfires. So 2 comma 3 is there, but for that 3 comma 2 is not there. So I hope you have understood it. Can I move ahead from here, students? Now here, we talk about anti-symmetrical relation as well. The slight difference here is that you need to understand is that if you have A to B and B to A, that should happen only when A and B are same. Otherwise, it should not happen. Everybody with me on this? Did you all get that? Now here, when I go ahead from here, transitive relation, that is something where a lot of students do get confused. And the best technique here is, the best shortcut if I could make you practice is, first of all, let us understand transitive, then we'll talk about that short technique. So if you have 1 comma 3, and if you have, let's say, 3 comma 7, so in that relation, if A comma B and B comma C is there, so there A comma C must also exist, which means if 1 comma 7 is also there we say that such a relation is said to be a transitive relationship. Everybody got that? Everybody understood this? Now from here, there is a small technique which I developed from one of the teachers. Here you can also adapt it. One of the very important and a very good method. For example, 1 comma 3, 1 comma 1, 2 comma 2, let's say 3 comma 1, and let's say 2 comma 3. These are all the elements which are given to you, right? And I need to check whether it is reflexive, symmetric and transitive or not. So the best thing is you do the mapping. So in the domain I can see 1, 2 and 3. So in the domain I can see 3 elements, 1, 2 and 3, right? So here 1 is mapped with 3, so I'll draw an arrow from 1 to 3. 1 is mapped with 1, so I'll draw an arrow from 1 to 1. 2 is mapped with 2, so I'll draw an arrow from 2 to 2. 3 is mapped to 1, so I'll draw an arrow like this from 3 to 1. And then I can see 2 is mapped to 3. So here 2 is mapped to 3, so I'll draw an arrow like this. Now, how do I define whether it is reflexive, symmetric and transitive or not? Of course, you can see it and decide, but if the data set is huge and if you ever get confused, this method definitely helps you a lot. Yes, it is called mapping. So here 1 is associated with 1, 2 is associated with 2, but is 3 associated with 3? No, that means it is not reflexive. What about it being symmetric? Sir, 1 is associated with 3, 3 is associated with 1, but there is a challenge, 2 is associated with 3, but I cannot see an arrow like this, which means I hope you all realize that this is again clearly not symmetric. I hope you are understanding it. The same thing or the same logic can be checked for it being transitive as well, which means what? If for transitive, the idea is really simple. Let's say 2 is taking me towards 3, 3 is taking me towards 1. So 2 should also take me towards 1. Did you understand this? From 2, I got to 3. From 3, I got to 1. So 2 should also have a link direct towards 1, which means if this link was not there, that means it is not transitive. I am glad that you are remembering all these techniques, Jeevan Ratham. That's brilliant. Somebody is saying I got 98 in January, 99 in physics and chemistry, but I lagged in maths. Now I feel very confident in maths, so there is possibility to get under 5K rank in mains. It all depends on a lot of things. First of all, the best thing which I can recommend you right now is solve as many previous year's questions as you can. That's the best resource to get better at it. And remember, do a proper analysis. Attempt a lot of mocks right now at this stage. So when you're attempting a lot of mocks, there you understand where do you lack. So go back to those concepts only. Don't revise the entire chapter. Just go back to that concept and revise those concepts. Everybody got this? So I hope you have understood this approach to check whether a relationship is symmetric, reflexive and transitive or not through this method. Now, if it is symmetric, if transitive and reflexive, then we say that the relation is equivalence. Now let's talk about functions. So when you talk about algebraic function, for example, if there is a function, linear function, for example, like this, then we call it a monomial. Polynomial means what? A constant function or an identity function. For example, y is equals to x. This is your identity function. Y is equals to 3. That's your constant function. I hope you're understanding it. You have rational functions, irrational functions. I hope you remember that. For example, if 2x plus 3 divided by x square plus 5. That's your rational function. Irrational functions are also there with some, p by q forms powers. So you already taught this. Okay, great, great. So with this kind of algebraic functions, classification is there. When you talk about transcendental functions, I hope you know exponential functions, a to the power x, e to the power x, they are your exponential functions. When you talk about logarithmic functions, we know y is equals to, if ln x is given, which means log is given at base e, or if you are given y log of x, and if the base is not defined, we assume the base is to be 10. Inverse trigonometric functions. So trigonometric functions are there, and then you have inverse trigonometric functions. I hope you remember sine inverse x, cos inverse x, and all. We'll be discussing their graphs as well, don't worry about that. Then you have piecewise functions. Their definitions are given piecewise. For example, when you talk about modulus of x, it has two definitions, plus x and minus x. Whenever x is greater than or equal to 0, plus x. Whenever x is negative, it is minus x. Signum function. I hope you remember mod x upon x. Greatest integer, least integer functions. I hope if you are preparing for JEE, you all are aware of these basics, right? Something very crucial from functional definition you need to remember and understand is this one. Whenever a question says, you can use this result directly, and questions are asked on this result. Let me highlight the importance of this particular slide. This is one of the most important slides. Take a note of it if you are not aware of it, and remember this result. This result can directly be used by you in the real examination hall. If you see, you are given that there is a function which is given like this, that f of x dot f of 1 by x is equals to f of x plus f of 1 by x. Then always remember this, that your function is going to be either 1 plus x to the power n or 1 minus x to the power n. Now sir, how do we decide the value of n and between plus and minus? Few more information will be given to you. Some more data will be given you. So with one data, you will be able to decide plus or minus, and with the other data, you will be figure out the value of n. So always remember, whenever a function fulfills this condition, that f of x into f of 1 by x is equals to f of x plus f of 1 by x, then this function will be taken like this. Other functional definitions you already know. When we talk about f of x plus y is equals to f of x into f of y and so on, a lot we have already discussed in the one-shots. But few important facts which should be highlighted, which you should remember, we are covering in this revision session. Jivanatham is saying, sir, I saw all your one-shots. It is very nice and useful. I am from Tamil Nadu. I can understand Hindi. I cannot understand Hindi. So this is very useful for me. Thank you so much. Jivanatham, we are also very grateful that we are there to help you or assist you in your journey. So good to be there in your journey. Now, as we discussed, logarithm is a part of algebra, but we are revising it here under the chapter sets, relations and functions. So look at this part. We all know few basic things. ln a at log of a at base a is 1. I hope you remember this. We all know that base should never be negative. Base should always be positive. That's the better word. And it should never be 1. Here, when we talk about base is raised to a certain power, then that power is taken as its reciprocal to the front, and you're given something like this. I hope you remember that. Log a base b can be written as 1 upon log b base a, something very simple and easy you must be aware of. If I wish to have my desired base, let's say log a base b, I can write it as log a base m divided by log b base m. You all are aware of it. Yes, Manit Chambyal, I am the same teacher who was there. Great. Thank you so much for highlighting it. Now let's study and prepare here. I hope you remember this is something very useful and worthy of remembering, that this is something which you use in integrating factor as well while solving linear differential equation of first order, linear differential equations. So there, remember this, a to the power log of something at the same base a is always gives you this m. I hope you'll remember that. And here, this a and b can always be swapped. This a and b can always be swapped. I hope you'll remember that. These conditions I hope you all are aware of since you are preparing for JEE, but a quick revision I'm giving. And if I now talk about something very crucial, when you talk about some important identities, when you talk about some important inequalities, this is something you must not forget. For example, here, when you deal with inequalities and when you deal with logarithm or exponential part, here you should be aware of it, that if log x and log y are being compared, and if you see the base to be greater than 1, then keep the same sign between x and y. But if the base is from 0 to 1, swap the sign, change the sign, interchange the sign. If it is greater than, make it less than. Same here, Manit. I hope you are getting benefited from these sessions as well. Now, similarly, I hope you know how to take the anti-log, something which you all are aware of. I hope you know that m is raised to the power b results into a, and that basic definition is which has helped you in developing log. Logarithm was nothing but this only. And the same thing is true for inequalities as well, but with this constraint, whenever base is greater than 1, and if I'm taking the anti-log, then m to the power b will be less than a if the base is greater than 1. But if the base is less than 1, then the sign changes, which means m to the power b will be greater than a. Everybody understood this? Can I move ahead from here? Again, this is something which is extension of the previous one. Now let's talk about ITF, inverse trigonometric functions. What is that here? I hope you know, first of all, sine, cos, and they all are periodic. Their inverse cannot be defined because they all are many one. So they are not bijective, and because of that, they are not invertible. But we restrict them, we confine them in their principal domain. And because of that, we are able to define their inverse. I hope you remember that. So if I talk about sine inverse x, what we do is, let me show you sine inverse x first of all. So when you talk about sine inverse x, we restrict sine x from minus pi by 2 to pi by 2. And because of that, of course, sine x happens from minus pi by 2 to pi by 2 between minus 1 and 1. So the range still remains minus 1 to 1, but here it becomes 1, 1. It becomes 1, 1 and on 2. And because of that, it is invertible. I hope you're understanding this. And if it is invertible, I can take its inverse. Even if you forget this, how I personally remember it, that sir, angles previously used to lie on the x-axis, now they'll be lying on the y-axis. So here you get pi by 2 and minus pi by 2. I hope you're understanding it. And at minus pi by 2 it is what? Minus 1. At pi by 2 it is 1. So these are going to be the 2 points. And here at 0 it is 0. Sine inverse 0 is 0, mind you everyone. So here you see its graph going like this. Concativity you can develop by yourself, but this is how you give a generalized result. Everybody getting this? Can I move ahead from here? Everybody. Now similarly, you see the other graphs coming into picture. The graph of cos inverse x. How do you draw it? Please remember the very basic idea that whenever you draw a line y is equals to x, and if you draw its mirror image, the mirror image of the graph with respect to this line, you find its inverse, which means if there is a function f of x, and if I could take its mirror image with respect to the line y is equals to x, then you get the graph of f inverse x. I hope you remember this fact. So even in a question, if there is, instead of mentioning that, let's say the question gives you a language like this, that there is a function g of x, which is the mirror image of the function f of x with respect to the line y is equals to x, which means what are they trying to highlight? They're trying to tell you that g of x is inverse of f of x. So this is how they play with the language. I hope you'll remember that. So this is how you see the graph of cos inverse x coming into picture. The very basic idea is at pi, it is minus 1, at 0, it is 1, and at pi by 2, sorry, I'm really sorry. At 0, it is 1, and at pi by 2, it is 1. I'm really sorry. At pi by 2 it is 0, and at 0 it is 1. So the inverse process is being taken, and with that you draw the graph of cos inverse x. Everybody got this? But you do remember, if sine inverse x was from minus pi by 2 to pi by 2, cos inverse x will be from 0 to pi. The same will be there for sec as well, and tan and cot will be going in the direction of, tan and cosec will be going with the sine inverse in terms of minus pi by 2 to pi by 2, although there will be some more constraints which we'll discuss, but I hope you are getting a decent clarity on this. When you talk about tan inverse x, please remember, this is how you see the graph of tan inverse x coming into picture. So it is from minus infinity to plus infinity this time. I hope you'll remember it, instead of minus 1 to 1, the way we have seen it from sine inverse x or cos inverse x, but here its range is still minus pi by 2 to pi by 2, but it will be an open interval this time. Everybody understood this? Can I move ahead from here? Are you all there? Understanding it? Just give me a quick response in the comment box. Can we run at this pace or speed, or do you want me to slow down? I hope it is fine. Can we go ahead with this quick revision of theory, entire theory, then we'll start solving questions. Now from here, these graphs are also there. Cot inverse x, I hope you can see and understand. Cot inverse x, and then we talk about cosec and then sec. I hope there is no confusion on that. Now few properties you must all be aware of is these properties of odd and even functions. I hope you know odd and even functions. I need not give you clarity on that. But when you talk about few more combined properties of odd and even functions, what do they mean? Product of two odd functions. It's like 2 minus. So product of two odd functions or two even functions is always an even function. Everybody, will you remember that? Product of odd and even is odd, which means product of minus and plus is minus, something like that. And here, all the functions can always be expressed as a sum of an even and an odd function. Please remember that. And how do we do that? Can you write it in the comment box? Okay, thank you so much, Atish. Thank you so much, Purvi, for that confirmation. Now, can you help me with this? How do you express a function as a sum of two functions? out of which one of them is even and the other one is odd. Can you write that expression in the comment box? I hope you remember, if there is a function f of x, I can always write it as f of x plus f of minus x divided by 2 plus f of x minus f of minus x divided by 2. So this part, with added this part, you always get f of x first of all in the conclusion, but this part is the even part and this part is the odd part. How many of you are aware of it? Do write in the comment box. From here, when I go ahead, what do I see? Please remember few more results. They are directly used as facts in the questions. When you solve questions, these facts, if you remember, you will be solving these questions with more accuracy, with more speed. So when you say, sir, there is no speed, I'm running short of speed, I'm using a lot of time, because you're not aware of these facts. So if you remember these facts, these points, your chances of solving a question in a quicker manner are high. First of all, the derivative of an odd function is an even function and vice versa, which means the derivative of an even function is an odd function. A function which is even or odd, when squared, becomes an even, because odd into odd or even into even will be even. I hope you understood it. The only function which is both even and odd is 0. I hope you remember that. So 0 is neither negative nor positive, neutral number. Similarly, when function's perspective we see it, it is an function which is both even and odd. So if in a question it is mentioned that there is a function which is both even and odd, then it simply means f of x is equal to 0 needs to be taken. Will you remember that? Can I move ahead from here? Now, few things which you should remember. Mapping, number of mapping. So here, how do I remember it? Let's say this was little same with the determinants expressing in terms of transpose and adjoint, something like that. Okay. Great. There is somebody saying a lot. Okay, so here, let me now talk about mapping of functions. These formulae, I'll move ahead out of the screen. Just take a screenshot of it or take a note of it. This particular slide and then this slide, take a note of it. Why am I saying so? Let me come back to this. When you talk about total number of functions, it is always r to the power n. What is r? What is n? The number of elements in codomain raised to the power number of elements in domain. If somebody asks you how many functions could be there. So the basic idea is really simple. Let's say in this set there are 3 elements A, B, C, and in the codomain set there are 2 elements D and E. Now I hope you're realizing the basic idea, the total number of functions which can exist here without any constraint, 1, 1, many, 1, on to, into, no constraint is imposed. You're simply asked the number of functions it can have. So from permutation and combinations perspective, how I remember it, sir, A has 2 choices, it can approach either D or E. Similarly, B has 2 choices, D or E. Similarly, C also has 2 choices, D or E. So 2 into 2 into 2, that is 2 cube. That's exactly what you are now dealing with. So number of elements in codomain raised to the power number of elements in domain give you the number of functions. Similarly, will you remember this number of 1, 1 functions? So 1, 1, what is the challenge? I hope you remember, if you want to have 1, 1 function there, you need to have this 1, 1 mapping. And if you want to have the 1, 1 mapping, there first of all, you choose those elements which are to be mapped, and in n factorial ways, you do that mapping. I hope you remember, if out of r elements in the codomain, I need to choose those n elements which are going to be mapped with those n elements from the domain, and then those n elements with those n elements from the domain to codomain can be mapped in n factorial ways. So basic permutation and combination, and if r is less than n, there will be no 1, 1 function. I hope you understood it. So if the codomain has lesser number of elements, it will be many 1 mapping. Everybody getting it? Everybody getting it? So otherwise, here in that case, there will be no 1, 1. Good to hear it from you all. Now from here, similarly, the total number of many 1 functions, this is how you do it. Total number of functions minus 1, 1 gives you many 1. Everybody got this? And total number of constant functions, that is r, either with this or this or this or this. So total r. Everybody with me on this. I hope you'll remember these formulae. Wouldn't forget them, because direct questions are asked on it. Now, when we talked about f of x plus f of 1 by x is equals to f of x into f of 1 by x, what was that expression, students? I hope you remember 1 plus minus x to the power n. I hope you wouldn't forget that. Similarly, there are some more functional definitions which you should remember for your examination. You should not forget them at all at any cost. Out of which the first one is, we all know, f of x, y, if it is given as f of x plus f of y, don't hesitate in taking f of x as k ln x. Here students commit an error. They take f of x as ln x and they forget taking k, and there they commit the error. To figure out k, some more information will be given in question, and there you get the right answer. A lot of time students make this mistake. They don't take this k, and that is where they commit the error. So I hope you wouldn't make that mistake. If you are given f of xy as f of x into f of y, in that case, don't hesitate in taking f of x as x to the power n. I hope you can see this property getting fulfilled. I hope you can clearly see this property getting fulfilled. If you are given f of x plus y is equal to f of x into f of y, again, students commit a mistake, which is they take f of x as a to the power kx. There again, you need to be careful that here they commit a mistake that they take f of x as a to the power x, which is again wrong. There you need to take f of x as a to the power kx. This k should be there with this and with this as well. Will you remember that? Can I move ahead from your students, all the participants? Similarly, if somebody says that f of x is equal to f of x plus y is equals to f of x is equal to f of y, which means this is clearly a constant function. And if it is a constant function, f of x should be taken as k. If somebody says f of x takes rational values for all x, if somebody says f of x takes rational values for all x, which means even if x is irrational, it is rational. When x is rational, then also it is rational. That means it is a constant function. Why are we discussing or talking about these lines? Because these lines are directly given in the questions. And there, you got to be aware of it. That if you are aware of this statement, you can directly utilize this as an information. For example, if in a question you are said that f of x takes all the rational values for all of x. So instead of bringing the conclusion and devoting a lot of time in coming up to the conclusion, you can directly say that, sir, f of x is a constant function. You can use this information and get the answer. Everybody with me on this, understanding this? Good, great. Now, few things related to graphical transformation you should be aware of. What are they? Let's say if I am drawing the graph of y is equals to minus x, and I know the graph of f of x. So I'll flip the graph about the x-axis. Everybody understanding this? I hope I need not demonstrate this. Simply flip the graph, because whatever values we were getting, of y, which is f of x, those will be negative now, because minus f of x is needed to be drawn. Similarly, if I wish to draw the graph of f of minus x, which means x is now negative. So this time, flip the graph about the y-axis. Few basic things I hope you are aware of. Sir, what all topics we'll be doing? Today, we'll be doing calculus, entire calculus. We have started with functions. The theoretical part we'll be doing first of the entire calculus, functions, then LCD, then derivatives, indefinite integration, definite area under curve, and differential equations. So entire calculus we'll be doing today. First, we'll be covering the theory in a very quick manner, the important concepts which are to be highlighted, and then we'll be consolidating them with a lot of previous year's questions. Are we clear on this? Now here, when I wish to draw the graph of mod of f of x, there what you do is reflect the parts of the graph that lie in the lower half, that is the negative part, into the upper half of the axis, and that's how you draw the graph of mod of f of x. Did you get that? Or if you didn't, let me just simply demonstrate it very quickly. Let's say this is a function over here. Let's say this is how a function is drawn. Let's say this is how, yes, application of derivatives as well. Entire calculus means entire calculus. I sincerely apologize for not mentioning that. Everything, entire calculus. AOD will be there after LCD and derivatives. Now here, if I get back to this, let's say this is the graph of f of x. So the lower part, the part which is below the x-axis, it will not be there because there f of x is negative, but its positive version will be there. So what you'll be having here is that this part will be vanished and its mirror image in the x-axis will be taken, which means this graph will go like this. Are you getting this? So this is how I will be having the graph of f of mod of x. Great, kindly clear all theory, sir. Yes, but Thish, I'll be doing the most important part. From scratch, we cannot do. From scratch, if you ask me to revise entire calculus, I think it will be really difficult. But the most important part, the chunk which is not missed, which should not be missed, which is something which is more important, which is there in your exam, definitely will be taking care of it in a very quick manner. Then we'll be solving a lot of questions. But yes, I am there in this live, constantly interacting with you all. Wherever you get stuck, wherever you don't understand any part of the question or concept, do ask me. I'll repeat that part. I hope you're okay with that. Now here, when you talk about f of mod of x, there what you do is discard the left part of the graph, that is the negative portion of x-axis should be removed, and take the reflection of the graph, the right part of the graph on the left side, which means let's say here you are having a graph. This is a graph. This is a function. Let's say this is a graph of the function f of x. Now I want the graph of f of mod of x. So what you do is simply remove this part of the graph which is on the negative side of the x-axis and take the reflection of this part, and this is how you draw the graph of f of mod of x from the graph of f of x. Everybody got that? Similarly, mod y is equals to f of x. These kind of graphs you deal with mostly in area under the curve, because there a lot of graphs are given to you and then you find area under the curve. But if you know the transformation of graphs, you can solve a lot of questions very quickly. For example, this one, mod y is equals to f of x. So what you do is discard the lower part of the graph, f of x being negative, and there take the reflection of the upper part of the graph into the lower half of the graph along the axis. The same definition. Everybody with me on this, or shall I re-explain this part? Give me a quick update on this. Now here, when I move ahead, when you add k to f of x, your function is shifted k units upward. If k is added to the x-axis, to the x part, which means f of x plus k, then it is shifted k unit on the left hand side if k is positive. If k is being subtracted, then it is shifted k units on the right hand side along the x-axis, of course. Left and right means x-axis, up and down means y-axis. I hope you all are aware of these things. If you are multiplying something by k, so k times it happens. So if k is greater value than 1 or minus 1, it gets expanded, or if it is between minus 1 to 1, then it shrinks. I hope you're understanding it. The same happens here as well. But if k is negative, then things change accordingly. I hope you're understanding that. Here, we are done with the theory of functions. I hope transformation of graphs is very well understood by you all. Now let's talk about limits. Few very important and very crucial expansions you must be aware of. Because if you are aware of these expansions, a lot of questions where the value of PQR, or for example, sometimes the value of ABC is asked in a lot of questions. Those questions can directly be done within seconds if you know these expansions. Some crucial and the important expansions I'll be highlighting. For example, you should not miss the expansion of e to the power x at all. If you are a JEE aspirant, you are aware of it, right? 1 x by 1 factorial, x square by 2 factorial, and so on until infinity. When it comes to a to the power x, do remember the only change happens here is x ln a, then x ln a whole square, then x cube, x ln a whole cube, and so on. 1 plus x to the power n, the binomial expansion is there. 1 nx by 1 factorial, n minus 1 by 2 factorial, x square, n minus 1, n minus 2, 3 factorial, x cube, and so on. I'm quickly giving you the glimpse of all the important versions which you should take care of. Something very important which you should not miss is the expansion of ln 1 plus x. Please remember this. This is always log 1 plus x, x minus x square by 2 minus x cube by 3, and plus, sorry, it should be alternate plus minus. So let me make that correction. First one is plus, second is minus, third one is plus, third is minus, plus, and so on. Alternatively plus minus. Everybody getting that? Please don't forget this. Do you not remember in the last mock test analysis, the rank booster mock 7, we did the analysis there. I highlighted this and I did tell you that one of the best questions of that paper we did with this particular identity. And I hope you must have remembered that that question could have taken a lot longer if you are not aware of this. And because of this, you should aware of this, that x to the power n minus a to the power n is always divisible by x minus a, no matter what is n, even or odd. Please remember that as a fact. So here, it goes like binomial only. You keep reducing the power of x and you keep increasing the power of a. This is how I personally remember it. So x to the power n minus a to the power n upon x minus a. So this x to the power n minus a to the power n is actually a product of this and this. Everybody getting that? Can I move ahead from here? Now, this is something you can remember, but these are the few ones which you must not forget at any cost. Now, with that, when I move ahead, few more. Sine, cos, tan, you should remember them because questions are asked where you use them a lot. The expansion of sin x, how I personally remember it, I always remember it like this, that sine and cos are what? Odd and even functions. So with the sine being odd, what we know is odd powers will be there. With cos being even, all the even powers will be there. And alternatively, plus minus will be there. Did you get that? And 10x is again an odd one. So power odd will be there. But coefficients you should remember. And its expansion till these 4 terms, you should not forget. At least these 3 terms, you must keep with you. Otherwise, you won't be able to solve a lot of questions. So with the 10x, you got to remember this expansion. There's no other substitute here. At least its expansion till these 3 terms must be memorized by you. Yes, I am a teacher of maths asking you to memorize. Please understand this. These are also there. Again, moving ahead, something very crucial. We do discuss it as a short trick as well. I hope you remember it. A standard short trick. Let's say you are given x is approaching infinity. A rational polynomial is there, which means a polynomial of degree m and a polynomial of degree n is there in numerator and denominator respectively. Now there are four possibilities. First possibility, if the numerator has a polynomial which has a degree lesser than the denominator, it will always result into 0. Do you remember that? If the numerator and denominator are the polynomials of the same degree, then the answer is always the ratio of their highest degree terms. So instead of a naught, it should have been b naught first of all. It should have been b naught. So the answer will be a naught upon b naught. Did you understand this? If the degree of the numerator is greater than the degree of the denominator, then your answer is infinity, given that these two terms are either both positive or both negative. Or if the degree of the numerator is greater than the degree of denominator, which is the same case as previous, but if they are of the opposite sign, in that case, it will be minus infinity. These two results are extension of this only, but just with some change. Okay, good to have you all. Yes, yo, hello, hi everyone, what's up? And what's wrong with the language? What's up? So as a teacher, what we, even in chats also, we write it more properly. What's apostrophe s space up and then question mark. But your generation, what's up? And better version of it, I have seen a lot of students, texting me like this, sup, question mark. Initially, I also got confused. What does it mean? Sup means what? But later on, I got the clarification. He was asking, what's up? Great. Good to have your generation right there in front of us. We are learning a lot from you. Now here, these are some basic direct results which you must not forget. There you need to understand. There, sin x upon x when x approaches 0 is 1. But here, you should take care of it that x is in radians. It is not in degrees. If it is in degrees, you change the result. I'll show you the result, but I hope you'll remember x should be in radians. Same result with 10x upon x, the same result with sin inverse x upon x, the same result with 10 inverse x upon x. I hope you will not forget this. By the way, my dear Gen Z, or whatever you are, however you define your generation, can you help me with this question? I'm just giving you, let's see how many of in the comment box do write the correct answer to this. I'll not be telling you the answer. I'm just asking it for the sake of understanding your awareness of the graphs. If you need the hint for this question, just keep the graph of sin x, 10x, and x in front of you. Do tell me what will be the answer to this question, limit x approaches 0, GIF of sin x upon x. GIF of sin x upon x. Do tell me the answer. I'm hoping for an answer from your side. Do write in the comment box. Let's see how many of you are intelligent enough to solve this. How do they write it? In the thumbnails, only people with great IQ can solve this. So let's see how many of you do it. Now, this is the one which I was trying to, one from the left hand side. Okay, with my class knowledge, I'll try to do it. Yes, Atiksh, that's good. From the left hand side or right hand side, Atiksh? Good. Ekaf V6V. What's your name, by the way? How do I call you? X plus H is 0. Ayush, why and how? Good, going great, everyone. Keep it up. Now, let us talk about these results as well. I hope you know, when it is in degrees, of course, to convert it into radians, you introduce here the arrangement, and because of that arrangement, it becomes pi by 180 degree instead of 1. So these few things you should be aware of it. If you are thinking that the limit exists here, then you're wrong. I'll simply suggest you to do one thing: apply LHL and RHL. And even if you're thinking that, sir, it will still be 1, then you are possibly a little or slight wrong. What I suggested you in the hint is, on the internet also, or even in our session also of trigonometry and of limits, continuity and differentiability, I tried giving you the comparison between sin x, among sin x, tan x and x. I drew all the three graphs, and there I tried showing you that why will it not be 1. Go through that video if you have not learnt it. But here again, I'll not be repeating the whole discussion. Here, I hope you remember x when approaches 0, it is 1. Here, if this part is 0, this part is also 0. So tan 0 upon 0 is 1. Similarly, sin 0 upon 0 is 1 if this part approaches 0. It is not indeterminate form. Go through that video. I have given you a crystal clear explanation on that. Okay, coming back to the discussion we are having, based on series expansions, I hope you know e to the power x we have just learned, and based on that, there are some more conclusions. E to the power x minus 1 upon x, where x is approaching 0, it always results into 1. If you forget this, you can apply L'Hopital rule as well. You can call me Ekaf or Mishal, it's my real name. The secret behind the real name is Ekaf is the word fake. Okay, great, great, great. I did not know it. So again, generation, right? Creative generation. So a to the power x minus 1 upon x when x approaches 0 is log a or ln a, log a at bc or ln a. Similarly, here, something very crucial. Here, okay, good to see you all there. I hope you know your offer is ending tomorrow. Your offer, the Vishwas Divas offer is ending tomorrow. I hope you are aware of it. So here, let's say you are given something like this, base and power. And when x approaches a, base approaches 1 and the power approaches 0. So it is 1 to the power 0 form. So the direct short trick here is that how do you write the solution? So the solution is really simple. Base minus 1 into power raised to the power e with that limit will be the answer. Did you understand this? If you didn't, just look at this expression and its direct shortcut. So instead of taking logarithm on both sides and then solving it and then taking the anti-log, don't do all of that. If you are given an expression base and power where base is approaching 1, power is approaching 0 or infinity, you can always apply this. Sorry, I'm really sorry. When the power is approaching infinity, it is 1 to the power infinity form, and that's the direct shortcut or solution for that 1 to the power infinity form. Will you all remember that? Can I move ahead from here? Yes, I am also, Mishal, waiting eagerly for 13th of April so that your batch starts and we all start teaching you for your 11th, 12th and droppers. For 11th, we have Arjuna. For 12th, we have Laksh, and for droppers, we have Prayas in pure English. But sir, in that limit you gave, sin x will be slightly less than x for all x positive. So the limit will be evaluated to slightly less than 0. When you do in GIF, it will go to 0. But Rags, if you're Rags, I'm trying to say you or suggest you that try to look at it from both the perspectives, LHL and RHL. Then you'll realize what's the error there. Did you get my point? Okay, great. Thank you so much, Mishal. Now here, when I go ahead with this, this is something which Newton and Leibniz gave. We are crediting it to them. So what did they give you? I simply suggest you this basic idea that let's say whenever you need to differentiate a definite integration, usually when do we need it? Either in limits based questions when we apply L'Hopital, or sometimes when AOD or area under the curve gives you questions like that where you are given a definite integration based expression and there you need to integrate it. So how do you do it? The basic idea is really simple here, students. Always remember, pass on this upper limit, hold on for a while, pass on this upper limit as a variable to this function into differentiate this upper limit, of course it is a function of x, and then minus pass on this lower limit to that variable t here into derivative of this lower limit. And that is the Newton-Leibniz formula of differentiating a definite integration. But there you need to be more cautious with the variables. Please understand, this when integrated with respect to t will give me an expression in t, but when I pass on the upper limit and lower limit, I'll get an expression in x. So I'm calling it to be a function of x. And this function of x is needed to be differentiated with x. So this result can directly be brought into picture. Instead of integrating it first and then differentiating, what you do is pass the upper limit to that function here and then differentiate the upper limit, minus pass that lower limit to that function and then differentiate the lower limit. Will you remember that? Can I move ahead from here? Everybody with me on this? From here, the most crucial formula, yes, evaluation of limits using sum. So integral as the limit, limit as a sum. This is what you should remember. What does it mean? I'll definitely be showing you a question and there I'll be highlighting or telling you what happens. All I am asking you right now at this stage to remember is that r by n is replaced by x, summation is replaced by integration dx. There r by n, when r is replaced by the lower limit, it gives you the lower limit. When r is replaced by the upper limit, it gives you the upper limit, where n approaches infinity. And there this 1 by n becomes your dx. So this becomes a to b f of x dx. If you didn't understand this, forget this. I'll explain this entire part with a question. A very decent PYQ I have deliberately kept to make you understand this concept. Purvi, are you trying to ask something? If you are, do write it in the comment box. Now with that, this is the crystal clear description of that, through which you can go, after watching this session. In the description of this session, I'll be attaching this entire PDF, all the notes, the entire theory of your calculus, with a lot of questions, with their theory, explanation and everything. So this entire PDF will be attached and you can revise this. Ekaf is saying, by the way, you'll see Mishal and Laksh batch. Okay, great. Sir, will you complete entire theory, then jump to PYQs? Yes, Purvi. First, I'll be covering the whole theory of calculus and then we'll be solving questions. We'll not be doing like this, that function, then it's question, then LCD, then it's questions. No. I'll do the theory first and then we'll solve all the questions. Because right now, it's not your preparation chapter-wise. You're not preparing for chapter. You're preparing for entire maths. So randomly, any question can be thrown at you. Although questions are also kept structured, but you should be mentally prepared for seeing any question from any chapter, any topic. And that's where we are saying that let's not go chapter by chapter. Let's keep it mixed, merged. Let's make it more chaotic. Let's create a mess here. And there you develop the knack, the ability to come out of the mess. Because this exam is all about handling that pressure, handling that mess. Because somebody once said this very beautifully, that diamond is nothing but a piece of charcoal which handled pressure exceptionally well. A lot of teachers, a lot of people have said it already. I hope you know it. Good to have you all. Now from here, this is something which you all are aware of. Theorems on differentiability, we know. Left-hand derivative, right-hand derivative, we all know. And if you know that, here you give the conclusion. But here I'm going to give you a very important theorem brought specifically from our notes. What does it say? Let's say f of x is differentiable at a, and f of a is 0 and g of x is continuous at a. I'm not aware of g of x differentiability at a. Hold on for a while, students. What I know is two things. That there is a product of two functions, f of x into g of x, where f of x is differentiable at a and f of a is 0, where I don't know about differentiability of g of x at a, but I know that g of x is continuous at a. Two things. Are you listening to this? Many times, a lot of lengthy, huge, complicated questions can be done if you know this particular property. So this is again one of the most important and highly loved properties of IDJ. They ask questions based on it. You don't realize it directly that this property is being used, but if you notice it properly, if you pay attention to it, you do see and it clicks, and there you mark it very quickly. Three things you need to notice. First of all, you will be asked to check the differentiability of a function at a point, which is going to be a product of two functions, out of which if you could figure out two things, that one of the functions is differentiable at that point, and at that point that function is 0, and the other function is continuous at that point. There, without delving further, without probing deeper, you can always conclude that this product is going to be differentiable at a. Did you understand this? Do write into the comment box if you understand, if you understood this fact, or I'll give you an example. Everybody with me on this? Will you remember this? So many times, a lot of questions. Of course, I'm not going to show you the proof. You need to remember this as a fact directly. But here, please remember this as a result, a direct result. Will you do that? Can I move ahead from here? All the participants who are watching it live? Yes. This is a shortcut which I wanted to discuss with you all, that how do you differentiate the implicit functions? How do you differentiate the implicit functions? Implicit, I hope you know, for example, of a function, if x and y cannot be segregated or separated, and there you need to find out the derivative. Now from LCD, we have moved towards derivatives, right? So how do we do it? I hope you remember. The short technique is, if I wish to find dy by dx, you differentiate the function with respect to x, keeping y as constant, divided by differentiation of the function with respect to y, keeping x as constant, and there you take negative of it. So negative sign is missing from this theory, and that is your dy by dx. Let me take an example as well. Do we have an example? I think we don't have. The basic example, if you want to take, let's say there is a function xy plus, let's say, sine x, right? This is a function. This is a function, implicit function, let's say it is. Even if we can, I'm not splitting it, I'm keeping it like this, and I want to find dy by dx. So how do you find dy by dx? All I'm saying is, if you wish to write dy by dx, take negative first, and what did we see? Partially differentiate this function with respect to x, divided by partially differentiate this function with respect to y. I hope in physics also you have studied the partial differentiation. That's exactly what I'm asking you to do. That's good. Mughal, Karu, na Karan. I hope everybody is listening and understanding this. Can I move ahead from here? All the participants, give me a quick update on this. How do you do it? Negative of partial derivative of this with respect to x. So here y will become or behave as a constant. In the denominator, x will behave as a constant, and I hope you know how to do it. Will you write the final answer for me? Can I move ahead from here, participants? The next conclusion, although what NTA says is that they have eliminated or omitted the concept of tangents and normal from their syllabus. Okay, so let's say it is omitted from calculus, but it is still there in coordinate geometry. So why should we not have a method to deal with tangent and normals from the calculus, so that if a question is asked, we could use either coordinate geometry's approach or calculus, because both could be helpful or advantageous if you know them. Because the more tools you have, the better you will be with your preparation, with your strategies, with your optimization. The quicker you will be in solving them. Ayush, if you are for NEET, if you are a NEET aspirant, why are you watching this? First of all, thank you so much for increasing the live count. Thank you so much for that. But why are you watching this? Now, if I get back to this, this is something very important you all should be aware of. For example, if there is a curve, second degree curves means what? First of all, it could be a pair of straight lines, but if it is not pair of straight lines, it could be either a circle, parabola, ellipse, or a hyperbola. So if it is a second degree curve in x and y, and if you are given a point lying on this curve, mind you, the condition is that the point should lie on the curve. And if you are asked to draw a tangent to it, what you do is, always remember, x square is replaced by x1, x1 comma y1 is a point on the curve. And on that curve, I need to write the tangent. So don't differentiate, then find its dy by dx, then tangent slope, and then writing the equation of the tangent. No. Not all is needed to be done. Here is a short trick, short technique for you. What is that? Okay, PCMB, good. So x square is by xx1, y square by yy1, x by x plus x1 by 2, y by y plus y1 by 2, and if you have a term in xy, xy1 plus yx1 by 2. Yes, good. Now, I hope you understood it. This is called writing t is equal to 0. So with t is equal to 0, you always get the tangent to the curve, second degree curves. And there you need to understand that here, all of these curves are second degree curves, and the point x1 comma y1 lies on the curve. Otherwise, this technique will not work. If the point is not on the curve, and if you do this method, if you apply this method, you are going wrong. Everybody got this? Can I move ahead from here? Now, the next part, which if I move towards, find the equation of tangent, a very basic example. I hope you can see it and understand it by yourself. We have kept this for you. This is already, we have already discussed. You can see, read and understand them. Now, let us talk. I hope I need not make you revise the formula of differentiation. Rather, all the formula of differentiation we can revise with the integration. How? Because I hope I need not tell you that derivative of x to the power n plus 1, derivative of x to the power n plus 1 will be x to the power n upon n plus 1. I hope you are understanding it. Sorry, n plus 1 into x to the power n. So here if I integrate this x to the power n, I'll be having this. I want to know what's extra in JEE. Okay, Ayush, great. So are you writing this JEE in the second attempt, in the April attempt? And if you are, these sessions are definitely for students like you. Everybody who is willing to revise entire maths with these 3 lectures, it is for you. But of course, it is an exaggerated version of it, that entire JEE maths can be done with these 3 sessions. No, of course not. But yes, it can definitely help you at this stage. Right now, whatever preparation you have done, whatever you know, can be consolidated, can be refined. You can make it better. That is what we are trying to do with these sessions, right? A quick theory first and then questions. Now, I hope you know, we know derivative of ln x is 1 by x. So 1 by x integration will be ln mod of x, mind you. Here, e to the power x is e to the power x, whenever either differentiated or integrated, doesn't matter. Rags is saying, sir, I just finished 10th. I use your videos to do full LCD differentiation, 11 trigonometry, full integrated. Wow, my goodness. Before even 11 started. That's good, Rags. And I am surprised and astonished by the fact that by those one shots only have you done it. I think in that case, don't do that. Because one shots are specifically designed for those students who have already studied these chapters in a very detailed format, and now they are willing to revise them, those chapters, with those one shots. And by the way, it's great that you have done the entire theory or entire 11th before it has started. That's brilliant. Okay, Ayush, good to have you. That's good, black mystery. Now, getting back to the discussion, we know a to the power x, when differentiated, gives you a to the power x ln a. So here, a to the power x, I hope you're understanding. I hope you're understanding. A to the power x, when integrated, gives you a to the power x divided by ln a. I hope you will not forget that. Here, few things I hope you remember, that differentiation of sin x is minus cos x. Sorry, I'm really sorry. Integration of sin x is minus cos x, because differentiation of minus cos x is sin x, because derivative of cos x is minus sin x. So I hope I need not make you revise these formulae. You already know them. Okay, Rags, that's good. That's brilliant. That's good, the kind of efforts you're making. I hope I need not tell you these formulae. Few important ones, remember this. Which ones, students? I'll be coming to those. Yes, here. The integration of cortex. With the right substitution, you learn it. But here, remember, integration of cortex is log of mod of sin x. Because log of sin x, when differentiated, gives you cortex. The same is true for 10x as well. Integration of 10x is minus log of mod of cos x. These two you must remember. Don't forget them at any cost. But with that, some few more special integrals come into picture. What are they? This one first of all. Here, the integration of sec x, the integration of cosec x, and these ones. These ones. Which ones? The integration of 1 upon under root over a square minus x square sine inverse x upon a. The integration of minus 1 upon under root over a square minus x square, it could be either minus of sine inverse x upon a or cos inverse x upon a. Similarly, for 1 upon a square x square, 1 upon a tan inverse x upon a. For minus of this, it will be 1 upon a cot inverse x by a or minus of tan inverse x by a. Okay. Great. Now, with this, few more things. I hope you can clearly see them coming into picture. Nothing much is needed to be highlighted. This is something for your JEE's preparation you should remember. First of all, integration is a chapter which we have seen with the January attempt as well. It was alternatively asked. Alternatively means, from probabilities perspective, I'm saying that, if there were 10 shifts, so there were 5 questions out of the entire integration. So we can expect out of 2 papers, in 1 paper, integration, indefinite integration, I'm saying specifically, was there. So it is not very important chapter, but if it is asked and if questions can be done, you should know the formulae. It's simply a game of learning the formulae. Yes, it is in the syllabus, Rags. So here, but they are to be converted into proper integrals. There are methods we'll be discussing in this part in the upcoming slides. Don't worry about that, Rags. So here, first of all, whenever you're given product of your trigonometric functions, because we cannot integrate these functions with these product form even if we use isolate version. So there, first of all, we convert them into summation. So product into sum we use, and there we get the integration done. Everybody understood that? What do I mean by that? Sin mx cos nx can always be written by half sin m minus nx plus sin m plus nx. Similarly, cos sin minus sin. I hope you're understanding it. Everybody with me on this without any confusion. But if it is sin cos, then I hope you know cos version will come into picture. I hope you know how. I'll move ahead with this discussion. Let me take a 10 minutes break. It is 5:10 right now on my screen in front of me. Let me have a 5 minutes break at least. We'll be resuming at 5:15. Okay. So we'll resume this session at 5:15. I hope you're okay with that. Let's have a 5 minutes break. You also take a break. I'll also have some water and then we'll resume this. Hi everyone. Just give me a quick confirmation. Am I clearly audible and visible to all the participants? So the break is over. I hope you can come back. Everyone, come back. I hope you all are there. Just do write in the comment box. Can you all hear me properly? Can you all listen to me properly? With this, when I move ahead, these are some basic or some important ones which you must not forget. These are the ones which are used in definite integration. These are the ones which are very highly used in area under the curve as well. Please don't forget these ones, because you do the entire question and then all of a sudden you see these formulae getting used and you don't know them. You waste all your efforts and time in doing that in that case. So these are special integrals which, if you could remember, will not only help you in indefinite but in definite and in area under the curve as well. So please remember them, please learn them, please memorize them, please by heart them. Thank you so much, Ayush. Now moving ahead with this, I hope you know we have already discussed this one, but these two, with the help of partial fractions, they are done. But if you could directly remember the formula, I'm not showing you the proof, you should remember the direct result. 1 upon x square minus a square is 1 upon 2a ln x minus a upon x plus a, and 1 upon a square minus x square is 1 upon 2a ln a plus x upon a minus x. Please remember these results. With that, few more come into picture. These we have already discussed, but this one I'll specifically like to highlight. This one, what does it mean? 1 upon under root a square plus x square. So this is ln x plus a square plus x square. If it is 1 upon under root a square x square minus a square, then it is ln x plus under root x square minus a square. So you can see some pattern over there and you can remember them like this. Not just that, remember this and this. It will be used further in upcoming formula as well, which I'll be discussing, and this will be using this one as well. How? Have a look at that. If I talk about this, under root a square minus x square, I hope you remember under root a square minus x square. So the formula is pretty simple. Now if you see the pattern, it is really simple. 1 by 2, 1 by 2, 1 by 2, x, under root a square minus a square, under root a square minus x square, under root a square plus a square, under root a square plus x square, under root x square minus a square, under root x square minus a square. So first part of all these formulae, I hope easily understandable. Now even the second part is also something very simple. What does it mean? Sir, half a square, half a square, half a square. The only change here is if it is x square minus a square, there will be minus sign. Sir, what is the next thing? Next thing is really simple. If I go back to the previous slide, under root a square minus x square, when it was 1 upon under root a square minus x square, it was sine inverse x upon a. So this will be 1 by 2 a square sine inverse x upon a. It was under root a square plus x square, so I hope you remember it was ln x plus under root a square plus x square. That's exactly what is happening here. And same with under root x square minus x square, this one. So these three, you could remember if you could see some pattern here and some relation of these three with these three. So these 9 formulae, which 9 students? 3 from here, 3 from here, and 3 from here. Take a note of these 9 formulae. Even if you can, take a screenshot here at this stage, then this stage, then this stage. Take screenshots and then move ahead. Keep revising them. The way you take medicines, morning, evening, afternoon, in the same fashion, keep revising them. Paste these 9 formulae in front of your study table. Go through them every day, because that's the only way to memorize them at this stage, right? Will you remember that? Can I move ahead from here? These are some right substitution, and the formulae which we have just discussed, the 9 special formulae, are derived with these substitutions as well only. So here, all I'm saying is the moment you see a square plus x square and integration is happening, substitute x by either a tan theta or a cot theta. And similarly, you follow the other substitutions as well, because of which you find the final integration. I hope you're understanding these basic terms. Now, when somebody was asking about the improper and proper fractions, let's develop the different techniques here. Let's say if I'm given 1 upon a quadratic. So do you know how to convert this quadratic into a perfect square? So when you convert this denominator into a perfect square, what you could possibly be getting is either 1 upon x square plus a square, or 1 upon x square minus a square, or 1 upon a square minus x square. Any of these. And once you could convert that quadratic in the denominator as either this or this, I hope you know how to integrate it. I hope you know the final integral. I hope I need not tell you this part. Everybody understood that. Now from here, if I get back to the discussion we all are having, if it is 1 upon under root over a quadratic, I repeat, if it is 1 upon under root over a quadratic. So again, for that, I hope you can see these formulae will come into picture, because 1 upon under root over a quadratic, that quadratic again with completing the square can be converted into under root over either a square minus x square form, or under root over a square plus x square form, or under root over x square minus a square form. And again, you know the integral formulae. Are you understanding my language? Since it is a quick revision, I hope you are able to understand my words. Now the third part is integration of under root over a quadratic. Integration of under root over a quadratic. Again, what you do is you convert this quadratic into a perfect square. And when you do so, you get any of these three. Either you get under root over a square minus x square kind of a form, or a square plus x square, or x square minus a square, and then again you apply these formulae. Everybody understood this, that whenever you deal with quadratic in the denominator, or under root over quadratic in the denominator, or under root over quadratic in the numerator, how do you solve these integration based problem? First of all, convert it into a perfect square, and then you know those 9 special integral formulas, after which you will get the next answer in the next step. Everybody understanding what I'm trying to say here at this stage in this revision session here? Now, if I now talk about few more conclusions, there is another type. What does it mean here? First of all, you will be given a linear upon quadratic, or a linear upon under root over quadratic, or a linear into under root over quadratic. Sir, how can we solve these two or these three cases? They are first of all converted into something, and then they are again solved with these approaches only. But how do we convert these into those previous type 1 cases? Let's have an idea on that. All I'm saying is that here, that quadratic, I hope this is the process of converting that quadratic into perfect square as we have discussed. Here, express the linear expression as a derivative of quadratic times lambda plus mu. For example, if the integration of, let's say, 2x plus 3 into under root over 5x square plus 6x minus 2 is needed to be done. So first of all I'm suggesting you to do is that this linear expression, which is what, 2x plus 3, express it as a times derivative of this 5x square plus 6x minus 2 plus b. I hope you're understanding it. Sir, how do we find a and b? You differentiate it, you get a linear on the left hand side, you get a linear on the right hand side. It is an identity, so the same degree terms should be same, so coefficients can be compared. So with that you can get a and b. Once you have received a and b, you substitute 2x plus 3 by this, because when you do that you get the right substitution, and then with the proper substitution you get the form. Which form? Now this form which we are discussing in type 2, these forms can be converted into type 1 forms. So are you understanding it? Whenever you are given a linear upon quadratic, or linear into under root over quadratic, or linear upon under root over quadratic, you simply express the linear as a scalar times derivative of the quadratic plus another scalar. Everybody understood that here. When I move towards the next case, the type 3, here, this is the other case. Now that's the case, Rags, when you were asking about if you are having an improper integral. How do we deal with that? Pay attention to this part. Let's say I have kx upon this, where kx is a polynomial of degree greater than 2. So if it is a polynomial of degree greater than 2, what do we do is, we first of all divide it. So when division happens, you get quotient, you get remainder, and that remainder will either be quadratic or less than quadratic, which means linear or constant. So with linear upon quadratic, we know what to do. With constant upon quadratic, we know what to do. Constant upon quadratic type 1, linear upon quadratic type 2. And this qx is going to be a polynomial whose integral you already know what to do, how to do. So I hope you're understanding when kx upon quadratic is given, where kx is greater than quadratic in terms of degree, cubic or biquadratic or pentic, then you divide it first, find the quotient, and then write remainder by divisor, and then you integrate it. And this part with either type 1 or type 2, you find the answer. Everybody with me on this? Can I move ahead from here? Now, how do we solve this particular case? Quadratic upon quadratic, quadratic into under root over quadratic, or quadratic divided by under root over quadratic, or quadratic into under root over quadratic. the same as linear upon quadratic or linear into under root over quadratic or linear upon under root over quadratic, but a slight change. What is that slight change? Pay attention to that. The slight change is pretty simple. The one part or the one quadratic, which is simply the quadratic, which is either in the numerator or numerator into under root 1. Under root 1 is needed to be differentiated. So this quadratic is the one which I'll be differentiating. I hope you're understanding it. But how do I differentiate it? I write this ax square plus bx plus c as lambda times this, lambda times whole of this quadratic plus mu times derivative of this quadratic plus mu. Sir, you have to turn the infinity to some b and then take limit as b tends to infinity. Which part are you guys talking about? What comments am I reading? Am I reading the previous comments? I think the comment box, let me refresh it. I think there is something wrong here. How do I fix it? Hold on for a while, students. Let me just refresh my screen. I think I'm not seeing the right comments here. So give me a moment, students. So you have to turn the infinity to some b and then take limit as b tends to infinity. For which part are you saying this, Rags? Sir, no sir, I meant like when the upper limit or the lower limit is some multiple of infinity. In that case, I think I'm missing something. Is it related to limits or integration? Yes. In that case, I'm not able to get the whole part completely, but yes, as far as I can recall. Sir, can you slightly increase your volume? Is there something wrong with the volume? Can you not hear me properly? All the participants, just give me a quick confirmation. I hope you all can hear me properly. आवाज़ कम आ रही है. एक बार चेक करना ना, माइक ठीक है? माइक ठीक है, आवाज़ कम आ रही है. अगर है तो बदल देना. Okay, let us get back to the discussion we all are having. Purvi, just give me a quick confirmation. Am I clearly audible and visible, all the participants? I think the voice is great. If it is still low, just give me a quick confirmation. Can you all hear me properly? I hope I'm very clearly audible to all the participants. Okay, thank you so much for that, Ayush. I think Purvi, you can increase the volume of your device little low. Okay, I'm trying to get it increased, but I think it is fine from our end. Now, let us get back to the discussion we were having. What are we saying here is a very basic idea or a very basic suggestion here that if you have a quadratic into quadratic, so one of the quadratics is written as lambda times quadratic plus mu times derivative of quadratic plus another variable or constant, arbitrary constant, and with that you again find the comparison, you do the comparison of the same degree term so that you can find lambda, mu and gamma, and through that you find the integration. So I'm asking if limits, where a limit is infinity, is there in syllabus? Yes, we did discuss it in integration. Yes, we did discuss it. We'll be discussing a lot of things. Just have patience. I'll try to show it to you. But I'm thinking I'm not able to get what you're exactly trying to say. Okay, good, great. Integrals of these forms. So trigonometric integrals also what we deal with. So how do we deal with these particular expressions? For example, 1 upon a cos square x, b sin square x, or something like this, or something like this, or something like this. First of all, pay attention to all these forms. Now, how do we deal with them? Very basic idea, very basic idea. All you need to do is divide the numerator and denominator by cos square x. So when you do that, either it becomes 1 or 10 square x, or the numerator becomes sec square x. So 10 square x or 10x can be taken as t. Sec square x dx will become dt and your job will be done. Everybody got that? But yes, it will be converted into some other forms as well, for which you already know how to deal with. Asif, you should, but I'll suggest right now, you should start it from beginning. Right now, we are on the verge of completing indefinite integrals, so you should watch it from the beginning. Otherwise, again, you will get confused. Okay, Asif? Now here, if I go ahead from here, I hope this form is very well understood by you all. Now, let's say instead of degree 2, I am having linear trigonometric. For example, a sin x plus b cos x or something like that. There also there is a technique. So what is that technique? Remember these two formulae. Sin 2 theta is 2 tan theta upon 1 plus tan square theta, and cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. If you remember that, you can do a lot with that. Because sin x, I can substitute by 2 tan x by 2 upon 1 plus tan square x by 2, and cos x we can replace by 1 minus tan square x by 2, 1 plus tan square x by 2. And with that, again, you take tan x by 2 as t. You will be seeing 1 upon at square plus bt plus c kind of a form, which is again type 1 or type 2, depending on what you do here. Everybody understood that? I hope you are understanding it. I'm not showing you the whole solutions, but I'm just giving you the ideas. This is also one of the methods which you could use, but I think the previous one is more effective or efficient here. This one, sir, when you have sin x and cos x in the numerator and denominator both, there you go with that quadratic upon quadratic approach. Sir, what do you mean by that? Let me try and show it to you here. Here, the thumb rule is simple, that substitute or replace or write the numerator as lambda times denominator plus mu times derivative of denominator plus gamma. Yes, Rags, we will have questions on definite integration where we'll be talking about when limit approaches infinity, limit as a sum. It is called limit as a sum. That concept we'll be discussing. It is definitely a part of your syllabus, of your JEE syllabus, right? I hope you have understood it. And again, quadratic upon quadratic kind of approach is being used, and with that you write the final answer. Next one. This is what we have already discussed. Now moving ahead with this one. Again, I'll say this is something which JEE loves asking. They are very much in love with this formula, and we have seen a lot of questions being asked on this particular formula. So if you're watching it right now, make a note of it that you do remember this. I'll be solving a question on it, but a better question on it. Not a direct question on it where you're simply asked to break a function into two functions where one of the functions is derivative of the other function. No, not just that, but a very good question. Very tricky and very simple question, can be done in 3 seconds or with 3 steps if you know this approach. Its better version will be highlighting here. So one of the versions is this. It's even a, modified version we'll be discussing there. So watch it till the end. We'll be discussing a good question on this. A question is there in this slide. Okay, can I move ahead from here? But I hope you remember it. You need not integrate. Whenever you see e to the power x into something, all you need to do is that something should be split into 2 parts, where the other part is derivative of first part, and there you write the answer as e to the power x f of x, the direct one. Will you remember that? Great. Now from here, when I go ahead, what do we see next? Here, let's say if I'm given psi x upon p root q, where here p and q are linear, which means this ax plus b into under root cx plus d. How do we do it? Always remember this part which is inside the under root sign, this linear expression cx plus d, just substitute it by t square. The entire expression gets converted into an expression of t, and there you know how to integrate it. You have already learned to deal with that. I'm just discussing the approaches here. Let's say you're given 1 upon quadratic into under root over linear. I repeat, if you are given quadratic into under root over linear, in this case, again, do the same thing, substitute that linear by t square. And again, you'll get the result which you know how to deal with. The third one, let's say you see 1 upon linear into under root over quadratic. I repeat, 1 upon linear into under root over quadratic, which means there substitute linear by 1 by t, and then again you'll get the results or the form which you know how to deal with. So make a note of it. This is the most important part where you should keep paying attention, because these are the different direct approaches, ideas, suggestions or tools I'm giving you, which you can directly apply in the examination hall and get the answers. Right? With this one, I hope you understood. 1 upon quadratic into under root over quadratic, again do nothing, but here pay attention. The term in x is not there. You are simply given ax square plus b and cx square plus d. There what you do is substitute x by 1 by t, and there again you get the form of which you know the integration. Everybody listening and understanding, watching it, getting clarity on all these different forms. If somebody is saying, sir, these are a lot of forms, will we really be able to remember them? Then I'll say, once this video gets over, start the integration part from beginning. Whenever you see a form getting discussed, look for a question on it and solve this. Of course, we are running short of time. We are having a limited time to revise the entire calculus. We'll not be able to do all the forms of integration, but what you can do is to memorize, to remember them, or to feed them into your subconscious brain, that you keep it as your muscle memory, that whenever you see a form, you know how to do it or what to do it. You simply see the form. When you revisit this video, watch it again, attempt a question on it, and then move towards the next form and the next form and the next form. That's how you can learn all these forms. I hope you have understood it. From here, integrals of this form, 1 upon linear to the power something into quadratic inside an under root. Again, this linear should be substituted by 1 by t and you'll see your form getting solved. Where you need to understand this r should be an integer which should greater than equal to 2. So this should have degree more than 2. Sir, what if we're stuck somewhere? In integration, yes, that's a problem that sometimes you get stuck, but I have tried covering all the cases as per your syllabus. All the possibilities I have covered here in this part. All possible forms and their approaches, that if this happens, then this do this, and if this happens, then do this. All the forms I have covered in a detailed format. And still, if you're not able to do it, then you won't be able to do it, because in that case, maybe the integral is not possible. There are integrals whose, integral cannot be found. I hope you remember that. Similarly, this version, I hope you have already seen it. You can see it and understand it by yourself. I'm skipping this part. Now, after integrals, let's talk about properties of definite integrals. Integrals, if it is lengthy and tough, it is not very high on investment, because there you study a lot and not much output you receive. Definite integration, area under the curve and differential equations are very, very high on return. High on return means a decent amount of investment, study, preparation, practice is needed to be done, and you get a decent output. Because one short question from definite integration, area under the curve and differential equations is always there. So with these 3 chapters, you get 3 direct questions based on these direct formula or properties which we'll be discussing now. So I hope you are paying attention to this final part of your quick theory revision of your calculus, where we are now beginning our discussion with definite integration, then area under the curve, and then differential equations. And after that, we'll be solving questions. Everybody understood that? Now, let's begin our discussion with the first property of definite integration. I hope I did not tell you, this is what you all are already aware of, that if I need to integrate f of x from a to b with respect to x, the change of variable does not affect your questions, where you say that f of t dt, a to b, will also give the same result. Because that variable, whatever variable is there, will be substituted by those limits, so it wouldn't matter at all. Everybody got this? Can I move ahead from here? Second thing, sir, I wish to swap the limits as per the need of the question. We'll have to do that. So whenever you wish to swap the limits, all you do is introduce the minus sign. So whenever you interchange the limits, give a minus sign. Yes, Yaksh, once this entire theory gets over, I'll be discussing all the PYQs. I'll again start from scratch. We'll be doing PYQs of functions, sets, relations, and then we'll move towards your limits, continuity and differentiability. Then we'll talk about differentiation, application of derivatives. Then we'll move towards indefinite integration, definite integration, and then of course area under the curve, and then finally differential equations. I'll be making you do everything from calculus. But first we are revising the entire theory in a quick manner. The important concepts at least, so that you don't forget them, you apply them in the examination hall, and then we'll be revising and consolidating all of them with a lot of questions. Did you get that, Yaksh? I hope I have answered your query. Mishal is saying, sir, I got the dream of idea right now. Mishal, let us study right now. We are preparing for these kids. Okay, we'll definitely talk about all of this, but right now our focus is these aspirants who are having their high priority exam in the April attempt. So let's help and assist them right now at this stage. Now let's focus on this f of x from e to b. Right, now what do we do here? We did discuss this one, I think. Now let's talk about this. King's property, they call it. Let me just read this query, sir. The reason I'm asking this, if you start from April, is it a reality that could I get above 9K or 5K? If not, just only focus on doing JEE Main's problems. What's your opinion? We'll discuss or talk about it in detail, Mishal. Don't worry about that. We'll definitely have a detailed discussion on this. We'll definitely have a detailed discussion on this. Okay, Mishal. I got your query. But right now, this is not the right moment here. We need to do some more important things. But the only thing I can assure you of is that since you have already enrolled, you're already watching a lot of lectures, you are getting a lot of insights. So don't worry about that. Just attend a lecture, revise the notes, and solve the questions. Trust me, the basic process does not change. The core process remains same. Study it, read it, imbibe it, revise it, understand it, absorb it, and then rehearse it. Go through it thoroughly, comprehensively. That's the process. If you keep repeating it, you are going somewhere really decent. Now from here, let us move ahead with this discussion. Properties of definite integrals, right? Now this property, f of x, 0 to a, can always be written as 0 to a f of a minus x. And this is a corollary of this property. Which one? This one. Which one do we have this? Yes. This is the actual King's property. Here, a to b f of x dx can always, as per the need, and we'll be doing a lot of questions on that, remember this, can always be substituted or written by a to b f of this x can be replaced by a plus b minus x. Please remember that. Don't forget that. I hope you will, everybody, and I hope most of you are already aware of it. Now from here, the next one. If I wish to split my integral as per the need of the question, because when piecewise functions come into picture, GIF, modulus ones, there you need to split your integration based problem. Definite integration I'm talking about. So there, how do you deal with them? The result is really simple. Let's say a to b is needed to be done. I can split it as per the need, a to c and then c to b, where c could be any real number. C need not necessarily lie between A and B. But here you need to remember this. If I'm splitting it into multiple C1, C2, C3, then you need to keep or maintain the order. For example, if A to C1, then C1 to C2, then C2 to C3, and so on until Cn to B, there you need to ensure that C1 is less than C2, C2 is less than C3, and so on. And ultimately, A should be the least value and B should be the highest value. Yes. Definitely. That's brilliant. You got my point. Everybody got this? Another property here is a pretty simple one. If 0 to a f of x dx is given, you can split this limit into half. It is 0 to a by 2 and then 0 to a by 2, then first of all f of x, then f of a minus x. Please remember that. Don't forget these properties. This is something which is again very highly used. JEE asks questions based on it, and I'll be showing you questions based on this where this particular property is used. Sir, for differential equations, I saw this thing called Laplace transform to turn differential equations into algebraic equations. Could you cover how to use and do this, sir? No, that is what you study when you study engineering. In mathematics 1, mathematics 2, mathematics 3, mathematics 4, you learn that. So Laplace transformation is not there in your syllabus. But that's a very good insight that you have given. Good, brilliant. When you do the engineering, you will study it. And I'm so glad that you brought this under my notice. We did study it when we pursued engineering. There you study it. You are also going to study all of this, Laplace, Fourier and everything, but during your BTech. Now, and if you are fortunate enough, for example, if you are having CSE branch, then you study all the mathematics, M1 to M4. Now, coming back to the discussion, remember minus a to a. So, whenever you notice negative to positive, minus a to a, just look at that expression. Can that expression be written as even or odd? Or if it is an even or odd function, or can it be splitted into an even or odd, or sum of even and odd, or something like that? And if you could do that, the even part is always nothing but what? Double of 0 to a. Or if it is odd part, it is always 0. The proof is really simple. Whenever you see an odd function, for example, something like this, they are always symmetrical with respect to the origin. So let's say from minus a to a, you are integrating. So from minus a to 0, this will be the area. From 0 to a, this will be the area. But when you do the definite integration, area comes with sign. So this will be minus a, this will be plus a. Minus a plus a will be 0. I hope you have understood this. But if it is an even function, it is always symmetrical with respect to the y-axis. So if the graph goes like this is capital A, this is minus a. So capital A plus, this is capital A. This is another capital A. So capital A plus capital A is 2a. That's exactly what we have seen over here. Everybody watching, listening and understanding this, are you all there without any confusion? Can I move ahead from here, all the participants? Now from here, when we go ahead, we talk about properties of definite integration based on periodic functions. These questions are also asked by JEE. How do we apply or use them? Pay attention to this. For example, if there is a function sin x and 0 to 10 pi is needed to be done. So for sine, we know the period is pi. So instead of integrating it from 0 to 10 pi, what I can say is 10 times 0 to pi sin x dx. Everybody with me on this, all the participants who are watching, listening and understanding it. Now from here, when we go ahead, we now talk about these properties. I'll be showing you the properties first. For example, here, let's say I need to integrate sine x from a to a plus 2 pi. Now what does it mean? Let's say there is a point A, so this is A. And what is a plus 2 pi? This is a plus 2 pi. So whatever region you missed from 0 to A, that region is brought here by this a plus 2 pi. So if you are asked to integrate a periodic function from a to a plus 2 pi, let's say, all I can do is 0 to 2 pi, I could introduce sin x dx. Are you all there? Everybody listening, watching and understanding without any confusion. Let me make a correction. I think previously, maybe just before one slide, I think I said sin x has a period pi. No, sin x has a period 2 pi, because I hope you can see 0 to pi and then pi to 2 pi. So this region keeps on repeating after every 2 pi distance. So my mistake, I think I have mistakenly said that sin x has period 2 pi, and I was talking about, I think, 0 to 10 pi sin x. In that case, you don't write it as 10 times 0 to pi sin x. No, please correct that. Here, it should be written as 5 times 0 to 2 pi sin x. Everybody getting it? Because the period of sin x is actually 2 pi, it's not pi. Thank you so much for correcting that if you have noticed it. I hope you are understanding the geometrical meaning of these properties and how are they getting derived. Same is true for a to a plus t. There again you do is 0 to t. Because a and a plus t will not make any difference even if you integrate it from 0 to t. Because it is periodic, it is repeating itself. So whatever area you get here, the same area you'll get here. I hope you all are listening, understanding and getting it. From here, when I now move ahead, I talk about these properties as we have already discussed them. A to a plus nt, we did discuss them, that it is from 0 to nt. There should be a correction, this is 0 to nt. So a to a plus nt. So this a to a plus nt doesn't matter. It could be written like 0 to nt. And for 0 to nt, we know the period is t. It can be written as n times 0 to t. I hope my language is understandable. You are clearly getting everything, whatever I'm mentioning here. Similarly, a plus nt, I think there is some correction. It is a plus nt to b plus nt. I repeat, it is a plus nt to b plus nt. So that nt and nt doesn't matter. It can be written like a to b f of x dx if it is a periodic function with period t. Are you all understanding it? Now similarly, a to b plus nt. So all you can do is a to b first and then b to b plus nt. And that b to b plus nt we know can be written as n times 0 to t. Are you understanding all what we are discussing, students? Just give me a quick confirmation on that. I repeat, definite integration based properties on these three special properties based on periodic functions. Will you remember them? Did you understand the logical explanation as well? Why is it happening? The graphical part through which you can understand it. Periodicity, they have repetition, and because of that, they will exist. Just give me a quick confirmation in the comment box. Everybody understood that? I hope we are going at the right pace. You are understanding everything. This is something which is not in your syllabus, but JEE asks. And if JEE asks, we should remember them. We should learn these results. Sir, why should we learn these results? Why cannot we derive it? If you are willing to derive it, time and again. And if you wish to waste your time, we are happy to do that. But as an intelligent student, you should try to save your time. So right now, before your exam, if you have some decent amount of time, and if you could learn a formula and apply it directly in the examination hall, why should you not save a lot of time by investing some time here? I hope you remember Abraham Lincoln has once said it. I think Abraham Lincoln it was, that if you have 6 hours to cut down a tree, you should spend the first 4 hours in sharpening the saw. So if you have those 6 hours right now, why are you not spending the first 4 hours in sharpening your saw, in intensifying your tools? The better you are with your armory, the better you will be performing in your examination hall. Because we all know the more you sweat in peace, the less you bleed in war. That's exactly what we are asking you to do. So try to learn these formulae. As per your syllabus, it is not there, but if you learn this, it is very widely used in your exam and you can get the direct results. What is the formula? I repeat, one of the very important formula, because if this you could remember, you can directly apply it in the questions and you can get the answers within seconds. What is the formula here? The formula is pretty simple one. If you see, this is a limited, this formula has its own constraints. The limit should be 0 to pi by 2 first of all, or it should be the sine or cos raised to the power n. raised to the power n, where n is a positive integer. Now, two things will be there. Sir, either n will be even or n will be odd. The answer is pretty simple. The answer is always n minus 1 by n minus 1 by n into n minus 3 by n minus 2, n minus 5, n minus 4, and so on until 1. Don't go ahead with this because you'll start getting 0. But if n is even, you add pi by to it. Add means multiply. Or if n is odd, you stop. What do I mean by that? I'll demonstrate a very simple example. Let's say you are given sine x to the power 10. This needs to be integrated from 0 to pi by 2. So if you start integrating it, you will get into a loop. You will waste a lot of time. But if you remember this Wally's formula, what does it say? Sir, n is even or odd? Sir, power is even. Then apply this. What does it mean? N minus 1 by n. Very simple formula it is. You need not even remember this. Just look at the pattern. N minus 1. 10 minus 1 is 9 by n. Now what you do is just keep subtracting 2 from it, which means from n minus 1, from the numerator subtract 2, from the denominator subtract 2. So here I'll be writing the answer here. I hope you're okay with that. N minus 1 by n. So 9 minus 2 is 7, 10 minus 2 is 8. 7 minus 2 is 5, 8 minus 2 is 6. 5 minus 2 is 3, 6 minus 2 is 4. 3 minus 2 is 1, 4 minus 2 is 2. Now, if I subtract 2 further, I'll start getting negative values. So there I stop. And I already knew that it was even, so I'll append a pi by 2 here in the end. Everybody understood this? So these are the short techniques. If you could remember, you'll be saving a lot of time in the real examination. So this formula was given by a mathematician, Wally. It has its own different variants and versions. I'm specifically discussing this one only, which is important one from your exam's perspective. Second property, if it is odd, then what happens? Let's say I'm solving another one. Let's say 0 to pi by 2. That's the limitation. The limit should be 0 to pi by 2. And there, let's say you're given cos x to the power 7 and it needs to be integrated. So again, I hope you're understanding it. N minus 1 by n, that's how we begin with. So 7 minus 1, that's 6 by 7. Now keep subtracting 2 from the numerator and denominator, that's it. So 6 minus 2 is 4, 7 minus 2 is 5, 4 minus 2 is 2, 5 minus 2 is what? 3. 2 minus 2 is 0. 2 minus 2 is 0. So there you stop. And with 0, you finally end it with 1. That's your answer. Isn't it interesting? Isn't it amazing? So with this Wally's formula, a lot of amazingly complicated and calculation based problem can be done within seconds. I think it will not take more than 10 seconds to write the final answer, if you remember that. So I hope you'll be using it as per the need. Can I move ahead from here? Everybody with me on this? Just give me a quick thumbs up if I have understood this Wally's formula. And if you were already aware of it, then also do write in the comment box. Then I move ahead with the differential equation. So we are on the verge of completing the theory part and then we'll start solving questions. Here, differential equations. So when you solve linear differential equations, I hope you know all you get is the standard form I'm discussing. It could be the dx by dy. That also case can be created, but here I'm discussing the standard case. Dy by dx plus p of x. I repeat, you're given dy by dx plus p of x times y is equals to q of x, right? So first of all, to solve this, we have a standard method, a decent direct approach. What is that, students? I hope you remember that. First of all, what you do is you find the integrating factor. That is e to the power p of x dx. Don't use any constant of integration. And then once you have found the integrating factor, you write the solution. Solution is given by y times integrating factor is equals to integration of q of x into integrating factor plus c. And there, this c is found by some additional information given in the question. Everybody got that? Can I move ahead from here? Now we'll be discussing some exact differential equations. A one shot is already going to be released. There I'll be discussing all of these. Don't worry about that. But I'm giving you the direct result. Whenever you see x dy plus y dx, replace it by dxy. When you see this, replace it by this. Sir, why are you giving these exact differential equations? Because a lot of questions, even without Bernoulli or linear or even, the homogeneous, don't use all of that. If you could see some pattern getting used something like this, you will get a lot of answers very quickly. How? We'll definitely talk about all of these. Right now, I am going to take another live for just 10 minutes. I'll be taking another live because I need to make an important announcement. So I'll be back in possibly in 15 to 20 minutes. It is 5 o'clock right now. We'll be back by 5:20. No. Homogeneous need not be skipped, Rags. It is not the difficult, neither longest. I'll show you the right approach. We'll be discussing a lot of questions on that. But I need to take a break of 20 minutes because I'm going to another live. If you want to watch that live is going to start at 6 o'clock on PW English Medium channel. So you can tune there. And then don't forget to come back here because the actual discussion is happening here of your calculus. So we'll be resuming our discussion in 20 minutes, okay? So we'll be resuming our discussion at 6:20. So let me just write that we are taking a break. Okay, I hope you're okay with that. We'll be resuming our discussion in 6 minutes. So there is a simple break. I hope it's visible here of 20 minutes. So we'll resume at 6:20. I hope you're comfortable with that. Is it visible to everyone? Just give me a quick thumbs up. It's something easy. Yes, it's easy, Purvi. Homogeneous and exact, both are some really simple and easy. So we'll be coming in 10 to 15 minutes. I hope you all can watch me live continuously on PW English Medium channel as well. There is a very important video coming up for you. I'm going to be there. So all these students who are watching it right now can switch to there and then don't forget to come back here. Okay? So just a matter of another 20 minutes. Thank you so much for that. We'll be back.